We move straight on now, dear ladies and gentlemen, to Hyungki Kim. He is Research and Project Manager at Hyundai Motor Company, and he will give us a closer look at the cost situation for the truck itself.
Good morning. My name is Hyungki Kim from Hyundai Motor Company's Fuel Cell Center. Today, I'm here to introduce you TCO analysis of commercial vehicle by NWP. That's right. I explained the vehicle unit and HRS unit efficiency analysis. Finally, the TCO analysis according to the filling pressure of commercial FCEV will be described. Next slide. It's a pleasure to have a chance to share the TCO analysis of commercial FCEV today. Before getting to the final TCO analysis result, let me explain the vehicle unit and the hydrogen refueling station unit data sequentially. Before getting to the point, please note that the meaning of the abbreviation is written in the upper right corner. Firstly, for the vehicle unit efficiency analysis, we take into account the three kinds of vehicles: the bus, a truck, and tractor of HMC. In this analysis, we set the volume of hydrogen storage system of each vehicle model, same for the both 350 bar and 700 bar system. This means, for example, we set the volume of HSS of tractor, same for the both 350 bar and 700 bar system. Secondly, we analyze the change of all electric range. This means the possible mileage of FCEV. As the number of tanks increases from the one to a certain amount suitable for each vehicle. Please refer to figure right side. Finally, we adjusted the HSS cost without tanks to increase as the number of tanks increase. Next slide. Following these methods, we can get the three results. The table right below is representing the data when the number of tanks is maximized. And please understand that the value is approximating due to confidential issue. Before we get into the main content, let me briefly explain the abbreviations. The CS stands for the HS cost per hydrogen storage, and HSS stands for the hydrogen storage system. Firstly, as you can see, the AR of 700 bar system becomes 1.5 times longer than that of 350 bar system, regardless of the vehicle model. Based on real and simulated data run from the development process, we can get the CS of 700 bar system approximately become 30% lower than that of 350 bar system. Secondly, as you may know, the OEM needs to consider not only the regulation of each country, but also enough shipping space for the economic activity of commercial vehicle. This means it's impossible to increase the number of tanks more than a certain amount due to the limited packaging space. Thirdly, from the real and simulated data, we found out the trend that the AR of 700 bar system becomes 1.2 times longer than that of 350 bar system when investing the same amount. As you know, 700 bar system can store hydrogen gas 1.6 times more than 350 bar system. From those reasons, we can once again confirm the advantage of the 700 bar system. Next slide. Let me move on to the second topic, the HRS unit efficiency analysis. Please note that the meaning of abbreviation is written in the upper right corner. In this study, we compare the economical efficiency of 700 bar and 350 bar system. Let me explain the specific method. It wasn't necessary to calculate the required quantity of HRS to provide the same vehicle driving range for each NWP system. To define the quantity and firstly the radius of circle describing vehicle driving range was set to be in proportion to 1.5 times considering the difference in AER. And then three assumptions were applied. The first one is that the durability of commercial FCEV is 10 years per 1 million kilometer, and the fuel efficiency is 11.2 kilometer per hydrogen kilogram. The second one is that the life of HRS is 20 years, and the subsidy and residual value is known. The third one is that about 600 commercial FCEV will be driven in the same driving area for 20 years. Next slide, please. The following these methods, we can get the result. By the second method on the previous slide, the refueling stations number had been properly adjusted to cover the same number of vehicles and same driving range. The approximate ratio of the number was found out to be 3 versus 10. You can see the capacity of compressor had also been adjusted to take into account the ratio. And please note that the three tables on the right represent the cost per 100 refueling station. The main category of HRS CapEx are the refueling equipment, civil and construction and ETs. As the main refueling equipment such as compressor, the dispenser, and storage account for a large proportion of the total equipment cost. You can see that the increase of the cost is slightly larger than other items. And it turns out the CapEx of 700 bar system is 3.26 times more expensive than 350 bar system. The main category of HR OPEX are including labor, electricity, the maintenance, ETs. As you know, the main key source of running the refueling station is electricity. Now, for this reason, you can see that the increase in the cost is much larger than other items. And it turns out the OPEX of 700 bar system is 3.26 times more expensive than 350 bar system. From the data of CapEx and OPEX, we can finally see the TCO analysis. Applying the assumption and variable mentioned in advance, the levelized cost of hydrogen LCOH of 350 bar system is slightly more expensive than that of 700 bar system. Please note that LCOH refers to the cost per kilogram that is set in consideration of all costs from refueling station construction to operation and vehicle production to operation. From the whole data mentioned in advance, we can get the cost per distance reflecting the cost of hydrogen storage system and hydrogen refueling station. Please note that as the working pressure of FCEV is already dependent on the HSS, the cost of other parts excluding HSS is considered to be the same. Considering the approximate durability of commercial FCEV is to be 1 million kilometers during 10 years, we can find out that cost per distance of 700 bar system becomes similar to that of 350 bar system. Next slide, please. This page shows the conclusion. In the European market, considering the existing 350 bar hydrogen refueling station, the HMC Hyundai Motor Company launched their hydrogen fuel cell electric truck at 350 bar. In Korea, a commercial hydrogen refueling station is being built at 700 bar under the government initiative. And in the US, a commercial hydrogen refueling station is being built at 700 bar under the leadership of the private sector. The cost of hydrogen storage system are dependent on initial market scenario, having similar cost between 350 bar and 700 bar system and TCO point of view. For a commercial vehicle, the mileage is one of the most important elements for vehicle productivity. From a short-term perspective, a 350 bar system is applied considering the current refueling station. And from a long-term perspective, 700 bar system is desirable to satisfy customer needs. This is the end of my presentation. Thank you for listening.